Hello, good morning students. In last session we discussed about resolving power, depth of focus, angular aperture and numerical aperture. Now today we have to discuss about the lens system of microscope, that is the objective and ocular. Okay, now objectives. The objective is the optical element that gathers light from the object being observed and focuses the light rays to produce a real image. Means the main function of the objective to gather the light from the object being observed and focuses the light rays to produce the real image of our object or specimen. Okay, so this objective is an optical part and it plays important role to visualize the specimen. Objectives can be a single lens or mirror or combination of several optical elements. Hence, actually here is the combination of lenses. They are present in the objectives. The objective lens is the lens closest to the slide or object you are viewing. Objective lens is that lens which is present nearer the specimen or object which we have to observe. The purpose of the objective lens is to gather light and enhance the magnification. The main purpose of objective lens to gather the light and enhance the magnification. Is it okay? Means when the light that is passed from the object, then there is a formation of image and that image that is visible after passing these light rays through the object. Okay, a typical compound microscope will have 4 objective lenses, and these 4 objective lenses, they are 4x, 10x, then 45x and 100x. Is it okay? That 4x, that is called as a scanning lens. 10x, that is called as a low power lens or low power objective. Then 45x, that is called as a high power objective or high power lens. And the last one, that is the 100x, that is called as a oil immersion lens or oil immersion objective. Means these are the 4 lenses or objectives which are mounted on a arm of the microscope. Okay, so these are the different lenses or objective lenses. They are mounted on the arm of the microscope. Okay, so this is the diagrammatic representation of the objective lens. See here, this is the objective lens. Okay, and this lens that is used for plane floor, and the magnification power of this lens, that is the 100x, and the numerical aperture of the immersion medium, that is 1.30. This objective that is specially designed. Okay, and there is a lens image distance, that is the infinity, and the cover sheet thickness, that is 0.017. So the working distance between the lens and the object or specimen, that is 0.21 micrometer, and this is the color coded ring for magnification. Is it okay? So this is the simple diagrammatic representation of the objective, and there are such a type of 4 objective. They are present in the compound microscope, and these 4 objectives, they are here. This is the scanning lens or scanning objective, and its magnification is 4x. Okay, now this is the another one, that is the low power objective, and its magnification is 10x. Now another objective, that is the 40x or 40 to 45x, that is called as a high power objective, and that high power objective that gives the magnification higher than the 10x lens, or this objective is called as a 40x or 45x objective. Now the last one, that is the 100x, and that 100x is also called as a oil immersion objective. That means in compound microscope generally there are 3 objectives. They are present. One is 10x, another is 45x, and last one, that is the 100x, that is the oil immersion objective. But now in modern microscopes there is one lens that is given additionally, and that lens is called as a scanning lens or scanning objective. Is it okay? Now these are the properties of microscope objectives. Here see, these are the different types of objective, that is scanning objective, low power objective, high power objective, and oil immersion objective. And at the left side there is a different properties of these lenses they are given. Here the magnification is the first property. The magnification of scanning lens or scanning objective is 4x. Okay, then low power objective magnification is 10x. Then high power objective magnification is 40 to 45x. In some cases there is a high power objective having 40x lens, and in some cases there is a 45x lens that is attached to the microscope, or that is mounted on the microscope. Is it okay? In case of oil immersion objective, the magnification power is 90 to 100x. That means here is also, in some microscope there is a 90x objective that is mounted, that is also called as a oil immersion objective. And in some microscope there is a 100x oil immersion objective that is mounted, and that's why both they are operated in oil immersion. That means there is a oil is necessary to observe the specimen. Is it okay? So another property, that is the numerical aperture. In case of scanning lens or scanning objective, the numerical aperture of that lens is 0.10. Okay, then in case of low power objective there is a 0.25 is the numerical aperture, and in high power objective there is 0.55 to 0.65, that is the numerical aperture. And in case of oil immersion objective there is a 1.25 to 1.4, that is the numerical aperture. And all these values, they are measured in micrometer. That means the value of numerical aperture that is measured in micrometer. Okay, the next property, that is the approximate focal length. and that focal length in scanning lens or scanning objective, that is the 40 millimeter. Okay, in case of low power objective, there is a focal length that is the 16 millimeter. In case of high power objective, the focal length that is the 4 millimeter, and in case of oil immersion objective, the focal length is 1.8 to 2.0, that means the 2 millimeter, that is the focal length. Okay, now the working distance is the another property. In case of scanning objective, the working distance, that is the 70 to 20 millimeter. That means this is the distance between the objective and the object which is to be observed, or that object that is also called as a specimen. Okay, that means the distance between objective and specimen. What is the distance? That distance that is called as the working distance. Okay, so that working distance in case of scanning lens or scanning objective, that is 70 to 20 millimeter. In case of low power objective, that working distance that is 4 to 8 millimeter. In case of high power objective, that means 0.5 to 0.7 millimeter is the working distance, and in case of oil immersion objective, there is a 0.1 millimeter is the working distance between the objective lens and the specimen or the object. Is it okay? Now the next property, that is approximate resolving power with light of 450 nanometer, that is blue light. In case of scanning lens or scanning objective, there is a 2.3 micrometer is the resolving power. In case of low power objective, the approximate resolving power is 0.9 micrometer. In high power objective, that is 0.35 micrometer resolving power, and in case of oil immersion objective, the approximate resolving power, that is the 0.18 micrometer. It is okay. Means these are the different properties of the objective. Is it okay? So next, these are the oculars. Oculars means that is also called as the eyepiece. The name given to this ocular lens, that is the eyepiece, because it is nearer to the eye, or through which we can observe the specimen, and that's why it is called as the ocular lens. And there are different types of ocular lenses. The smallest magnification of the ocular lens is the 5x, 10x, 15x, 20x, and in some cases there is a 25x. These are the ocular lenses that are used in the compound microscope. Specifically, general compound microscope, there is a 5x, 10x and 15x eyepiece or oculars. They are generally used for the visualization or for the magnification of the particular image. Is it okay? Now again, these are the different types of lenses. Means here is 5x, 10x, 15x, 16x, then 20x, then 25x likewise. But generally these three, that is 5x, 10x and 15x lenses, they are used to visualize the image. Okay. Now the limit of resolution of light microscope, the largest useful magnification, the level of magnification needed to increase the size of the smallest resolvable object to visible with the light microscope can be determined our eye can just detect a speck that is 0.2 millimeter or near about 200 micrometer in diameter, and consequently the useful limit of magnification is about 1000 times the numerical aperture of the objective lens.